Adding and subtracting radical expressions is very similar to when you're adding um, variables. So if I had a problem like 2x plus 3x, those are like terms, and you could add those together and make 5x. But if I had 2x and 3y, I cannot add those together because those are not like terms. So if I have different pieces right here, I'm not allowed to add them together and make 5xy or anything like that. So that is not allowed. So something similar to this, as I already said, is I could make 2x plus 3x be 2 radical x and 3 radical x. And these are the same, they're alike, so I'm allowed to add them together to make 5 radical x. Now that we know that, let's try an actual problem from your assignment. So we'll start with number 9, which is radical 5 plus 6 radical 5. Well, you should know by now that if there's nothing in front of a variable, there's really one of that thing. The same is true for this radical. This is really 1 radical 5 plus 6 radical 5. Because these are alike, these radicals are alike, I'm allowed to add the pieces together. So it's 1 something plus 6 something, which makes 7 something. So your answer for number 9 is 7 radical 5. They're not always as easy as that first example, so I'm going to move to one that is subtraction instead of addition, and also the radicals are not alike, at least not to begin with. So the first one I see that's like that is 13. 13 is 3 radical 7 minus radical 63. So I'm going to begin by writing 3 radical 7 because there's absolutely nothing I can do with that expression. I don't know the square root of 7. I can't break it down at all. So it'll stay as is for now. But I know for 63, I can change this into 9 times 7. And so again, I'm going to write down the 3 radical 7, but now I'm going to change this to the square root of 9 is 3. So I'm going to bring that out. And radical 7, I can't do anything with, so it'll remain radical 7. So now my problem is 3 radical 7 minus 3 radical 7. Well, that's the same thing minus the same thing. So your answer would be 0 for that one. The next section, 21 through 29, basically is asking you to distribute. You'll notice there's something on the outside of a set of parentheses and something on the inside of the set of parentheses. So you're just going to treat this the way that you would normally do if you had a distribution problem. So for 23, we have 3 radical 7 times the quantity of 1 minus radical 7. So I'm going to use arrows just so you can see what I'm doing. So I'll start with 3 radical 7 times 1. Well, 1 times anything is just itself, so that will remain 3 radical 7. And now I'm going to do 3 radical 7 times negative radical 7. So there's really a 1 here. 3 times negative 1 would be negative 3. And radical 7 times radical 7, well, that's a pair of 7s. It's really the square root of 49 if I was to combine these together. So radical 7 and another radical 7 would just be 7. Square root of 49 is 7. So I'm going to put a times 7 here because that's what it means when you have a radical sign up against another number. So I'm going to clean this up a little bit. I get 3 radical 7 at the beginning of my problem, and negative 3 times 7 is negative 21. That would be my final answer. I can't go any farther with that. We'll finish with an extremely difficult problem. This section gets a little crazy down here on 30 through 35. And remember that math does not allow you to keep a radical in the denominator. So you're going to have to do kind of a lot of work to get rid of the radical in the denominator. It's going to be very confusing, but try your best. I'm going to do number 33. So that is radical 5 in the numerator and 2 minus radical 5 in the denominator. So to get rid of something in the denominator, you need to multiply it by its opposite. And the opposite of 2 minus radical 5 would be 2 plus radical 5. And remember in math, if you're going to change the denominator, you need to change the numerator as well so that you're not actually changing the problem. So I'm going to start on the top because that's a little bit easier to do and distribute. So radical 5 times 2 would be 2 radical 5. And then radical 5 times another radical 5 would just be 5. So I've distributed completely on the top, nothing else I can do with that. On the bottom, we're going to do, you can use foil, you can use cover up, you can use a box. I would think the box would get a little messy. So I'm just going to use foil. And remember, we have 2 things here, and we have 2 things here for a total of 4 things. So I should have 4 things multiplied all together. So I will start by multiplying the first thing in each of the set of parentheses. So 2 times 2 is 4. Now, my little and big smileys, if you remember how I called them that, we have negative 2 radical 5, and we have positive 2 radical 5. So those cancel each other out. I'll write them down just so you can see them, 2 radical 5 and negative 2 radical 5. But those make 0, which is the whole point of doing this, is so that we can get rid of our radicals. And lastly, I have the last piece of each set of parentheses to multiply by each other. So a negative radical 5 times a positive radical 5 would be negative 5. So to clean this up, my final answer would be 2 radical 5 plus 5 in the numerator, and then 4 minus 5 in the denominator would just equal negative 1. A much nicer way to write that would be negative 2 radical 5 minus 5, and that's it. But I'm okay with you leaving it as a fraction because this problem was pretty difficult to begin with.